Alright, today we're going to practice finding the derivative using the definition of the derivative. This is going to be the limit process where we take the limit as delta x goes to 0 of f of x plus delta x minus f of x all over delta x. Okay. The first example we're going to do is f of x equals 4x squared minus 3x plus 1. Now when we put that directly into our definition here, we're going to have limit as delta x goes to 0 of 4 times the quantity of x plus delta x squared minus 3 times x plus delta x plus 1 minus the whole quantity of f of x, which is 4x squared minus 3x plus 1. And this is all going to be over delta x. The biggest mistakes happen here. This is where you have to use that algebra knowledge and try and expand and simplify. So we're going to take limit as delta x goes to 0. I'm going to go ahead and expand that first. So 4 times x squared plus 2x delta x plus delta x squared. Alright, I'm going to save all my distributing for the end, or not the end, the next step. (3x plus 1) all over delta x again. Alright, here I'm going to go ahead and do all my distributing. So I'm going to distribute the 4 to everything. So 4x squared plus 8x delta x plus 4 delta x squared. Distribute the negative 3, so negative 3x minus 3 delta x plus 1, and then distribute the negative to everything. So 4x squared plus 3x minus 1. Again, all over delta x. Now, if this is done correctly, everything that does not have a delta x should cancel out. It's kind of your first indication of if you made a mistake somewhere. So if I look at this, the 4x's are going to cancel out, the 3x's are going to cancel out, and the 1's are going to cancel out. Now this leaves me with 8x delta x plus 4 delta x squared minus 3 delta x all over delta x. Now you notice they all have a delta x. So now the next step would be to go ahead and factor out the delta x out. So I have 8x plus 4 delta x minus 3. At this point, the delta x's cancel. And so what you're left with is the limit as delta x goes to 0 of 8x plus 4 delta x minus 3. Well, at this point, you can put that 0 right in for the delta x, leaving us with 8x minus 3. And that is our derivative. F prime of x would equal 8x minus 3. So that is the limit process using the definition of derivative to find the derivative of this function. Let's go ahead and do one more example. Okay. So let's go ahead and do f of x. Let's do negative 2x squared minus 6. Alright, with this one, same process. We're going to go ahead and do the limit as delta x goes to 0 of negative 2 times x plus delta x squared minus 6, and then minus the whole function, quantity of negative 2x squared minus 6 all over delta x. Alright, well the only thing I have to expand is this one. So let's go ahead and expand that so it gives me x squared plus 2x delta x plus delta x squared. And again, I'll save my distributing for the next step. This can all be done in one quicker step, but just so you see all my steps, I want to do each one out. Alright, so I'm going to distribute the negative 2. It leaves me with negative 2x squared minus 4x delta x minus 2 delta x squared minus 6. I'll distribute my negative plus 2x squared plus 6 all over delta x. Again, if you did this right, everything without a delta x should cancel. So there's my 2x squareds and there's my 6's, leaving me with limit as delta x goes to 0 of negative 4x delta x minus 2 delta x squared all over delta x. Now again, they should all have a delta x. I can factor that out. Take out that delta x, leaving me with negative 4x minus 2 delta x. Delta x's then cancel. All right, leaving you with the negative 4x minus 2 delta x. Here's where I can go ahead and put 0 in for that delta x, leaving me with just negative 4x. And so my derivative of f prime of x is going to equal negative 4x. Okay, so there's two examples of the definition of derivative. The same process applies to every other function. Okay, sometimes you have to do a little bit more algebra involved, but for polynomials, that's pretty much what it looks like.